Hi everyone, we're going to find the points on the given polar curve r equals 1 plus cosine of theta where the tangent line is horizontal or vertical. So first we're going to look for the horizontal tangent line. We need the derivative of y with respect to theta. So what we need is our y, and our y equals r sine of theta. You substitute in your r and you get y equals 1 plus cosine of theta times sine of theta. So now let's differentiate that, and we're going to get derivative of y with respect to theta equals, copy this down, 1 plus cosine of theta times the derivative of sine, which is cosine of theta. And then you're going to take derivative of cosine of theta, which is negative sine of theta, times sine of theta. This gives us, if we simplify, 1 plus cosine squared of theta minus sine squared of theta. Now what I want to do is write everything in terms of cosine, so I'm going to write this as 1 minus cosine squared of theta using my Pythagorean identities. So I'm going to get 1 plus cosine squared of theta minus 1 minus cosine squared of theta. This is going to give me 1 plus cosine squared of theta minus 1 plus cosine squared of theta. And this didn't work. Hi everyone, we're going to find the points on the given polar curve r equals 1 plus cosine of theta where the tangent line is horizontal or vertical. So for the horizontal one, what we're going to do is take the derivative of y with respect to theta. So our y equals r sine of theta. You substitute in your r, and you get y equals 1 plus cosine of theta times sine of theta. Now we can differentiate our y with respect to theta using the product rule. So copy down the first term times the derivative of sine, which is cosine, and take the derivative of your first term, which is going to be negative sine, and then copy down your second term. Now I'm going to simplify this. Distribute this, you get cosine of theta plus cosine squared of theta minus sine squared of theta. Now what I want to do so I can solve for my angle theta is write sine squared of theta equals 1 minus cosine squared of theta. So that way I can factor. So I'm going to write this first. You have, doesn't matter, cosine of theta plus cosine squared of theta minus 1 minus cosine squared of theta. All right, let's simplify this. Let's put this first. You have cosine squared of theta plus cosine of theta minus 1 plus cosine squared of theta. So basically we have two of these. So that gives us 2 cosine squared of theta plus cosine of theta minus 1. Now we want to set this equal to 0 to find the horizontal tangent, and we can factor this as 2 cosine of theta minus 1 times cosine of theta plus 1 equals 0. So we have cosine of theta equal 1/2 or cosine of theta equals negative 1. That's going to give me my angles as pi divided by 3, pi, or 5 pi divided by 3. So basically we're going to have horizontal tangent at 3 points. Pi divided by 3, pi, and 5 pi divided by 3. We have to substitute in to find our value here. So cosine of pi divided by 3 is 1/2. So that's going to give us 3/2. At pi, it's going to be -1, so 1 minus 1 is 0. And at 5 pi divided by 3, that's also going to give you 1/2, so that's going to be 3/2. So these are the points where the tangent line is horizontal. Now let's do the vertical. The vertical, we're going to do the derivative of x with respect to theta. And before we start on that, that means our x equals r cosine of theta. Therefore, x equals, substitute in this, you get 1 plus cosine of theta times cosine of theta. So we're going to differentiate that. Let's do that. So we're differentiating our x with respect to theta now. And let me write again what it is. It's going to be 1 plus cosine of theta times cosine of theta. That's what we're differentiating. All right, here we go. This is going to equal negative 1 plus cosine of theta times sine of theta. I just differentiated that and brought the negative in front. Minus cosine of theta times sine of theta. All right. Simplifying this, I'm going to factor out a sine. So this is going to equal negative sine of theta times 1 plus 2 cosine of theta, because you can add these two once you factor this out. Set this to 0, and you're going to have sine of theta equals 0 for this one, or cosine of theta equals negative 1/2. So that means our angles are going to be 0, pi, 2 pi divided by 3, and or 4 pi divided by 3. So our vertical tangents are going to be at, we have 0, substitute that in, and you're going to get 2. At 2 pi divided by 3, substitute that in, and you're going to get 1/2, because that's going to be negative 1/2. So 1 minus 1/2 is 1/2. And at 4 pi divided by 3, substitute that in, and you're going to also get 1/2. Now, the tangent is horizontal when theta equals pi. All right. It's not vertical when theta equals pi. And that's because, so I only did these three. But the reason it's not vertical is because the limit as theta approaches pi of derivative of y with respect to theta divided by derivative of x with respect to theta. I know I'm squeezing this in here, but it equals 0. So it's only horizontal and not vertical. Thank you. Have a nice day. Bye-bye.